what this picture illustrates is that most Industry 4.0 solutions are like building a golden roof on a shack. They have an existing infrastructure, an existing concept of process that runs on their production line, and all they do is they put some data collection, some analytics on top of that, and it's like building a golden roof on top of a shack. You're not fundamentally changing how your production line works. So welcome to another Thursday Thought. This is why a data-driven production line has to be the foundation in which you build your production processes going forward. I believe that real Industry 4.0 solutions are going to be data-driven assembly lines. So what is a data-driven assembly line? So the first part, and probably the most critical part of a data-driven assembly line, is the data model. Data model is where we define everything in the production line, and I'll get into a little bit more detail as to what goes into the data model just now. The second part, and I think this is the part that people forget about most often, is actually the digital infrastructure on which you build your production line. So these are the communication protocols to different devices or machines on the shop floor, your databases, your server, your infrastructure, your networking. These are critical elements in an Industry 4.0 production line that have to be defined first before you start putting anything on paper from a mechanical design perspective or an electrical design perspective. So first, define your data model and define your digital infrastructure. The first input to the data model is, what should the line do? And that's basically comes from your bill of materials, your bill of process, and that gets aggregated into two parts. The one is a set of work instructions that you would display to humans or operators on the shop floor. The second part of that is actually the operations and machine settings that would be sent to machines to perform certain tasks. And all of that is set up initially inside the data model, ideally through a no-code interface. The second part of it is actually then building your production line on top of this digital infrastructure and data model. So this is everything from a completely manual process, a completely automated process. It really comes down to the product and the process that you need to execute on the shop floor. So some examples and some more details around why I think this digital infrastructure and building your hardware on top of your digital infrastructure is so important is shown and illustrated in this video. So here's a production line that's running ODIN Workstation, this data-driven manufacturing execution system from us. And as you can see in this video, the operator and the machines are being orchestrated by ODIN. So there's a screen that defines the work instructions. The machines are getting different settings based on feedback from the different processes that are being performed on the production line. And basically, this manufacturing execution system is orchestrating the human and the machine in a coordinated way based on data that is being inputted from different devices and feedback from the operator. This is a fundamental part of why getting the data to drive the machines and getting feedback from the machines and then in a live way and then adapting the process based on the data you get from the machine. The second part of this is really around quality data. So we've defined in step one what to build. We've controlled in step two how we've built it and actually built the product. And we only know how we've built it if we've collected data to validate that. We only know that we built a good part when the data can confirm the process was done correctly. Or we know that the process was done incorrectly, also based on the data we've collected, so the not okay parts. And I just wanted to give you a flavor of what some of this data looks like. So I'm going to open up a certificate of compliance that we deliver on all of our data-driven production lines. So over here you see a typical report for a single product produced on a data-driven production line. So over here I can see all of the operations completed. I can actually see that there was one process that wasn't done. I can see which operator performed each operation. I can see the deviations. So in this case, the pinion barcode was a deviation and who was responsible for the deviation. These are all the sort of results from the machine. So it could be torque results. The confirmation results are when you have an operator that has pressed the button to confirm that a certain step has been performed manually. Check results are when devices have confirmed that the process is done correctly. And so on. Gauging results are results from leak testers, measurement systems, etc. So that's a certificate of compliance that comes out that confirms from a data perspective that the product is actually built correctly. The fourth part of this whole infrastructure is actually really centered around rework and rework management. As we all know, the reality is things go wrong on a production line. And so we have to build into the data model right from the beginning what happens and how we handle when things go wrong, or exceptions on the shop floor. So here's an example where a car has failed in the 4th station on a particular process. The system can be set up to continue building the car, or it can be sent completely offline straight away from that point. It then arrives in a designated rework area. The operator can scan that product into the station, and that rework operator now gets a very detailed set of information on how to rectify the problem. So that could be a complete disassembly, it could be a partial disassembly, and that can all be defined again in the data model, and that gets instructed to this rework operator. And then the most important part is that we can then reintroduce that product into a station, say 2 stations ahead, and only the operations that were disassembled are actually performed on this part. This saves our customers huge in terms of cost of scrap and cost of quality at the end of the day. The 5th element in this whole infrastructure is really around analytics. And I think people talk a lot about analytics, and they talk about how they're getting lots of information, but I think 90% of the data that's collected on production lines today is actually not used. And the 10% that is collected is only used retrospectively. So when something goes wrong, can I go back into the data and have a look and see what happened? What we want to do is we want to use data proactively to define what I need to do tomorrow, as opposed to figuring out what happened yesterday. And I think that's a fundamental difference on how analytics need to be used. One of the biggest challenges with collecting huge volumes of data is to get context around each of those data points. And by default, by following step 1, step 2, step 3, and step 4 in this process, we are indirectly collecting good contextualized data. So the data collection process is actually not a task at all. It is actually built into the system because we need the data through the process. And so as a result, we can now build analytics platforms much faster, much quicker, and much more effective for our customers. So let me give you an idea of what some of the data we can, that advanced data we collect out of the platforms. So the first chart I want to share with you is really around what we call operation trends. And as you can see from this, what we're doing is we're in the background monitoring the cycle time of every single operation on this production line, 150 plus operations. We're monitoring the cycle time of every single operation on this floor, almost 1,000 operations that are running on this production line. And what we're doing is we're doing a trend analysis to see which operations are getting slower and slower. And what we do is we then present the top 10 the worst performing operations right at the top. And if I scroll on, you get to see the white dots, which represent stable operations in terms of cycle time. And if I continue scrolling on, you see the green dots that represent operations that are getting faster and faster, which is generally a positive thing. And if I were an industrial engineer, my job would be to come and have a look at this chart, not waste time doing cycle time analysis and checks, click on a particular operation, see what's happening, and I need to go and solve this problem. So it almost becomes an industrial engineer's to-do list every single day. They don't have to go and identify problems and look for operations or look for bottlenecks. This is all done automatically because I've got good contextualized data. The second chart that I want to share with you is really around live CPK analysis. And for those of you that don't know what CPK is an algorithm that we apply on all quality measures that are performed on a production line. So if I'm measuring a leak test, for example, I can do a CPK analysis, and that basically tells me how accurate and how stable my operation is. And what we're doing, again, on these thousands of operations, all automatically, is performing a live CPK analysis and bringing to the surface the operations that are completely unstable. So this becomes the to-do list for quality engineers. So as a quality engineer, I can simply come to work, have a look at this chart, look at a particular operation, I can click on it, and I get much more detailed information on the performance of a particular operation, and I can actually go and start solving problems as opposed to wasting my time collecting data. And the last chart that I want to share with you in terms of analytics is the operator feedback. So this is a dashboard that every single operator can access on their own station by putting their ID badge into the station. And over here, what we show on the right-hand side is the operations that particular operator is getting faster and faster at. And more importantly, we show also to the operator the operations that they're getting slower and slower at. And so the operator can then make a decision, is it something that I need to improve on, or is it a maintenance issue? And they can proactively call maintenance to support them to solve this particular problem. And this is this idea of data-driven behavioral change. So if we can empower operators with the right data so that they can make improvements on the production line autonomously of management and production heads, etc., then we fundamentally change the game for manufacturing operations. So that's a little feeling and just on the surface of some of the data analytics that we can pull out of a data-driven production line. And then the last part of it is really around how do I use ML and AI to predict what's going on. And for the sake of time, I'll link in the video, in the description below, a link to a dedicated video I've made on the use of ML and AI on production lines. But from a conceptual perspective, I think what's really important here is that once I have all the analytics and I can apply machine learning, I can start to predict when things might go wrong. And then if I want to use AI, I can start to prescribe particular machine settings that would improve quality, that would improve throughput. And because I'm a data-driven production line and I have a data model, I can feed the output of the AI back into the data model. And then in essence, what I end up with is an autonomously improving production line. So it self-improves on its own. And this is why getting the data model up front, the data infrastructure set up correctly at the beginning is fundamental to applying and using data to improve your production line. Here's another Thursday thought.